Hi, this is GCSE 9 to 1 Crammers. It's never too late to start revising, and this way you can do it anywhere. Listen to these questions as many times as you need until the answers pop into your head. Today we're revising Chemistry, Topic 2A, the bonding and structure of elements, and we will be covering types of bonding, ionic bonding, covalent bonding, and metallic bonding. This is a very important unit, and you need to memorize it well. You'll be using the knowledge in this unit to determine what type of bonding holds any compound together that you come across in all topics covered in chemistry. Test yourself by pausing the video after each question and trying to answer it. Then play on to check if you got it right. Keep going over the types of bonding until you get them all right and can answer the question faster than me. Different types of bonding. Ionic bonding is when metals react with non-metals. They form ions. Ions are charged particles formed when atoms gain or lose electrons. Metal atoms lose an electron, becoming positively charged ions. Non-metal atoms gain an electron, becoming negatively charged ions. Metals are oxidized. Oxidation is the loss of electrons. Non-metals are reduced. Reduction is a gain of electrons. Use the acronym OIL-RIG to remember it. OIL stands for oxidation is loss of electrons. RIG stands for reduction is gain of electrons. Covalent bonding is between two non-metal atoms. It is when a pair of electrons is shared between two atoms. They form either in non-metallic elements or non-metal compounds. Metallic bonding only happens in metals. Metallic bonding is the electrostatic interaction between positive metal ions and delocalized electrons. They lose the electrons to form positive charges. The structure and properties of ionic bonds. Ionic compounds have a giant ionic lattice structure, which are held together by strong electrostatic forces, which are oppositely charged ions pulling in all directions. Most metal chlorides are ionic, for example sodium chloride salt crystals, and most metal oxides are ionic, for example potassium oxide or nickel oxide. What are the properties of ionic compounds? They have high melting points because breaking strong electrostatic forces takes a lot of energy. They are soluble in water. Ionic compounds only conduct electricity when molten or dissolved in water or in a solution, because the ions are free to move and carry a charge. For example, potassium chloride dissolved in water conducts electricity. Ionic compounds do not conduct electricity when they're solid, because the ions are held in a fixed position and they're not free to move. Learn the key facts about ionic bonds well. They relate to every chemical reaction in all the chemistry topics. Make sure you can spot if the product of a chemical reaction will be an ionic compound. Know which elements in the reaction gain or lose an electron. Know what oxidation and reduction mean. Can you describe the structure of an ionic compound? And do you know the properties of ionic compounds? Try answering these exam-style questions. If you get any wrong, then go over the key facts again until you get them all right. What are the properties of ionic compounds? Ionic compounds don't conduct electricity when solid. They can only conduct electricity when in a solution or molten. They have high melting points and they're soluble in water. Solid potassium chloride does not conduct electricity. Explain why. Solid potassium chloride does not conduct electricity because the ions are not free to move. Explain why sodium chloride solution conducts electricity. Sodium chloride is an ionic compound in a solution, which can conduct electricity because the delocalized ions can move and carry a charge. What could the student do to the potassium chloride to make it conduct electricity? Potassium chloride would have to be dissolved in water, so the ions are free to move and carry a charge. Sodium oxide contains Na positive ions and O2 negative ions. Give the formula of sodium oxide. Na2O. Titanium chloride is a liquid at room temperature. Explain why you would not expect titanium chloride to be a liquid at room temperature. Metal chlorides are ionic, so they're solid at room temperature because they have strong electrostatic forces between the ions which need a lot of energy to break. Titanium chloride is a metal halide which unusually has a low melting and boiling point, so requires little energy to break the bonds, resulting in it being a liquid at room temperature. Magnesium chloride contains magnesium ions Mg2+, and chloride ions Cl-. Describe in terms of electrons what happens when a magnesium atom reacts with chlorine atoms to produce magnesium chloride. One magnesium atom forms an ionic bond with two chlorine atoms. Magnesium loses 2 electrons, and each of the chlorine atoms gain 1 electron, forming magnesium chloride, and each of the atoms now have 8 electrons in the outer shells, held together by electrostatic attraction. Describe the structure and bonding in sodium chloride. Find both these elements on the periodic table. Sodium is a group 1, an alkali metal, and chlorine is group 7, halogen nonmetal. Therefore, they are a metal and a nonmetal, which means it will be ionic bonding. Now describe the structure and ionic bonding features. Ionic bonds have a giant lattice structure, which is held together by electrostatic forces. Sodium is a metal and will lose an electron, becoming positively charged ion Na+. Chlorine is a non-metal and will gain an electron, becoming negatively charged ion Cl-. Nickel is extracted from nickel oxide by reduction with carbon. Explain why carbon can be used to extract nickel from nickel oxide. Carbon is more reactive than nickel, so carbon will displace nickel. Explain why solid zinc chloride does not conduct electricity and could not be used in an electrolysis experiment. Zinc chloride is a solid ionic compound which can't conduct electricity because it doesn't have any free-moving ions. Zinc chloride ions can only carry a charge when in a solution or molten. Covalent bonds. Atoms share electrons, joined together by intermolecular forces which can be very weak, strong, or very strong. Breaking weak intermolecular forces doesn't take a lot of energy, whereas breaking strong intermolecular forces takes a lot of energy. Very weak covalent bonds are made up of simple covalent bonds, which are made up of small molecules. Compounds and elements with weak covalent bonds are mostly gases and liquids at room temperature, because weak covalent bonds have low melting points and low boiling points. Compounds and elements with weak covalent bonds don't conduct electricity because they have no ions or delocalized electrons, like halogens in group 7, elements that have weak covalent bonds. Strong covalent bonds are large covalent bonds, which are solids at room temperature. Properties of strong covalent bonds are high melting points, high boiling points, and most don't conduct electricity. Very strong covalent bonds are made up of giant covalent bonds, which are solids at room temperature. For example, diamonds, graphite, silicon dioxide. Very strong covalent bonds have very high melting points and very high boiling points, and most don't conduct electricity. But it depends if they have delocalized electrons, like graphite. Examples of covalent bonds. Very weak covalent bonds are made up of simple molecules. Note that you need to learn the following examples of weak covalent bonds and how to draw the atoms and the bonds between them for the exams. Hydrogen, H2. Chlorine, Cl2. Hydrogen chloride, HCl. All have one single covalent bond. Water, H2O, has two single covalent bonds. Nitrogen, N2, has a triple covalent bond. And methane, CH4, has four single covalent bonds. Strong covalent bonds are made up of large molecules, known as polymers. Chemical compounds with long molecules bonded together in long repeating chains. For example, polythene. Remember, every plastic is a polymer, but not every polymer is plastic. DNA, proteins, etc. are also polymers. Most polymers are insulators, so they don't conduct electricity. Very strong covalent bonds are made up of giant covalent structures, for example diamonds, and each atom forms 4 covalent bonds. Diamonds are hard, they have high melting and boiling points, and diamonds don't conduct electricity because they don't have any delocalized electrons. Silicon dioxide. Each atom forms 4 covalent bonds. Silicon dioxide is hard. It is what sand is made of. It has a high melting and boiling point, and silicon dioxide doesn't conduct electricity. Graphite. Each atom forms 3 covalent bonds. Graphite is soft, has a high melting and boiling point, but where it's different to diamonds and silicon dioxide, graphite does conduct electricity because it has delocalized electrons. You might be thinking, do I need to learn all these examples? And the answer is yes, you do. You could be asked to draw or name the number of covalent bonds they have and their properties. In any question, be able to spot any of the very weak covalent bond examples. Allotropes of carbon are different structural forms of carbon. In the exam you could be asked a question on any one of these examples. First, graphene is a single layer of graphite joined together in hexagons. Graphene is light and strong. It has a giant lattice structure joined together with strong covalent bonds with weak forces between molecules. So layers of molecules can slide over each other. Therefore, graphene can conduct electricity. Nanotubes are fullerenes, a hollow tube of carbon atoms with a high tensile strength. This is the maximum stress that a material can withstand while being stretched or pulled. A nanotube is very light. It is also a good conductor of electricity. Nanotubes have many uses. For example, they're used as strengthening materials in tennis racket frames and in electronics. Fullerene is a hollow ball of carbon atoms, also called buckyballs, joined together in hexagons and pentagons. They are used in medicine. It traps the drug inside its sphere, then delivers them to anywhere in the body. Or as lubricants. They have weak forces between cages, so it's easy for cages to slip over each other. Fullerenes can be used as catalysts. They increase the rate of a chemical reaction, but are not used up in the catalyzed reaction, and therefore can be reused. Diamonds are hard and made from carbon atoms, which have a giant covalent structure. Diamonds have high melting and boiling points, and they don't conduct electricity because they don't have any delocalized electrons. Graphite is made up of layers of strong covalent bonds with weak forces between layers, so layers of molecules can slide over each other. Therefore, graphite can conduct electricity and resists high temperatures. Graphite can be used as a lubricant like grease, in pencils, electronic products, for example electrodes, batteries and solar panels. If an element has a low melting point, what does this mean? The element will have weak intermolecular forces. Explain why graphite can conduct electricity. Answer in terms of the structure and bonding in graphite. In graphite, each carbon atom forms 3 covalent bonds. 1 electron per carbon atom is delocalized, and these electrons carry charge through the graphite structure. Explain why graphite is a lubricant. Because there are weak forces between layers, so molecules can slide over each other. Explain why graphene is strong. The giant lattice of atoms in graphene have very strong covalent bonds, which need a lot of energy to be broken. Each atom in diamond is bonded to how many other atoms? 4. Do diamonds have a high or a low melting point? A high melting point. What type of atoms are diamonds made of? Carbon atoms. Most diamonds found in meteorites are nanodiamonds. How many atoms does a nanodiamond have? A few hundred. Drill heads also contain diamonds. Describe the structure and bonding in diamonds. Diamonds have a giant lattice structure with strong covalent bonds, and each carbon atom forms 4 bonds. Name the type of bond between the carbon and hydrogen atoms in methane. Both carbon and hydrogen are non-metals, so they have covalent bonds. Name the element shown in the structure below. Read the questions carefully. They're asking for the name of the element, not the name of the structure. The answer is carbon. Why does carbon conduct electricity? It has delocalized electrons that can flow freely through the structure. Name the type of bonding in a molecule of water. Because water, H2O, is made up of hydrogen and oxygen, which are both non-metals, the answer would have to be covalent bonds. Hydrogen atoms and oxygen atoms chemically combine to produce water molecules. Complete the figure below to show the arrangement of the outer shell electrons of the hydrogen and oxygen atoms in a molecule of water. 2 single covalent bonds and 4 unbonded electrons around oxygen. Why does pure water not conduct electricity? Because water does not have any ions or delocalized electrons. Silicon dioxide has a very high melting point. Other substances are added to silicon dioxide to make glass. Glass melts at a lower temperature than silicon dioxide. Suggest why. Glass has weaker bonds. Explain why the bonding in iodine is similar to the bonding in chlorine. Iodine and chlorine are both halogens, non-metals from group 7, and they form weak covalent bonds and share 1 electron to get a full outer shell. Show the bonding in the 2 outer shells of 2 iodine atoms. Draw 2 iodine atoms with 1 single covalent bond. Explain why iodine has a low melting point. Iodine in group 7 have weak covalent bonds, which are held together by weak intermolecular forces that don't need a lot of energy to break. Explain in terms of particles why liquid iodine does not conduct electricity. Iodine does not have any delocalized electrons, therefore cannot carry a charge. Ammonia has the formula NH3. The diagrams show how electrons are arranged in nitrogen and hydrogen atoms. Draw a diagram to show how the electrons are arranged in the outer energy level of an ammonia molecule. Nitrogen and hydrogen are both non-metals and form covalent bonds which share electrons. The formula NH3 tells us there is one nitrogen atom and 3 hydrogen atoms. Ammonia is a gas at room temperature. Explain why ammonia has a low boiling point. Ammonia is made up of simple covalent bonds, so there are weak intermolecular forces between the molecules. Explain why diamonds are hard. Each diamond atom is made up of 4 giant covalent bonds, held together by very strong intermolecular forces. Chlorine reacts with hydrogen to form hydrogen chloride. Explain why hydrogen chloride is a gas at room temperature. Answer in terms of structure and bonding. Hydrogen chloride is made up of small molecules, held together by weak intermolecular forces that require little energy to break. Explain why chlorine Cl2 is a gas at room temperature, but sodium chloride NaCl is a solid at room temperature. Chlorine is a gas at room temperature because the 2 atoms are held together by weak covalent bonds which have a low boiling point, so it does not take a lot of energy to break the weak intermolecular forces holding them together. Sodium chloride is a solid at room temperature because it has a giant ionic lattice structure, held together by strong electrostatic forces that need a large amount of energy to break. Sodium chloride has a high melting point. Metallic bonds are held together by electrostatic forces between metal atoms and delocalized electrons, which are very strong. For example, magnesium, gold, copper, etc. Metallic bonds form a giant lattice of positive metal ions arranged in a regular shape, and delocalized electrons shared between all the metal ions. Because metallic bonds are very strong, they have a very high melting point and very high boiling point. Metals are malleable. This means they can be bent and shaped. Because layers of atoms can slide over each other, metals can conduct electricity and thermal energy. Because the delocalized ions are free to move, most metals are solids at room temperature, except mercury, which is a liquid at room temperature. Metallic bonds, alloys. Alloys are a mixture of 2 or more metals to make them harder than pure metals, which are soft. Why are alloys harder than pure metals? It is because the different elements have different sized atoms. The new element atoms distort the layers of metal atoms, making it more difficult for them to slide over each other. What type of substance is an alloy? A mixture of 2 or more metals. Explain why the alloy is harder than pure zinc. Alloys have different sized atoms and no layers or rows, so they cannot slide. Gold is a metal. Describe the structure of a metal. Metals form giant lattice structures in which the atoms are arranged in a regular pattern. Magnesium is a metal. Explain why metals can be bent and shaped. Metal can be bent and shaped because the atoms form layers that can slide over each other. Explain how electricity is conducted in a metal. Metals are made up of giant lattice structures with delocalized electrons, which can flow freely through the whole structure. Suggest one reason why coins are not made of pure copper. Copper is a pure metal and is too soft. Drill heads are made from steel. Steel is an alloy. Explain why alloys are harder than pure metals. Different elements have different sized atoms, so the layers of atoms in steel and alloy are distorted, and there are no rows for them to slide over each other. Why is iron described as an element? Because iron is made up of only one type of atom. Suggest why pure iron would not be suitable to be used for a replacement hip joint. Because iron would not be strong enough. Explain how copper conducts electricity. Copper is made up of giant lattice structures with delocalized electrons, which flow freely through the whole structure. In this video, you've learnt about the bonding and structure of elements, ionic bonding, covalent bonding, simple molecular substances, larger covalent substances, allotropes of carbon and metallic bonding. Take time to memorize all of the content on this topic and aim to answer questions faster than me, so you can nail those exam questions in the Chemistry GCSE Paper 1. The key to exam success is learning, consolidation and keeping this topic fresh in your mind. How do you do that? Repetition, repetition and repetition. If you go over this enough times, you'll be able to answer any questions on this topic confidently in your exam. This is GCSE 9-1 Crammers, and if you like the content of this video, give us a thumbs up. And if you have a question or need help, give us a comment below. And don't forget, smash that subscribe button if you want more Crammers videos for your exam success. Thanks for watching and see you again soon.